All right, well, welcome to this tip talk from AIMOS. Let's get straight into it. But first of all, it's very important to acknowledge that I live and work on the lands of the Turrbal and Yagara people. And I work at QUT and acknowledge that where QUT stands has always been a place of teaching and learning, and that these lands were never ceded. And I pay my respects to elders, laws, customs, and creation spirits. So we've got 12 tips lined up. At the end, we can have a quick Q&A, or if somebody else has suddenly thought of a tip they want to share, we're very happy to hear that too. So please mute your microphone unless you're one of the speakers, in which you're going to need to quickly unmute and then mute again. So first up is Marina. Oh, and it's going to be 3 minutes each, so it's rapid fire. Let's go, Marina.
Yes, rapid fire. Thank you, Adrian. Hi, everyone. Yeah, I'm Marina. And so my mini tip here is really actually just about papers. And so it's maybe slightly different than a lot of the other ideas here. And there's maybe a few use cases. So one is like redundancy. You don't want to miss something if it's already been done. So not missing literature, even though there's so much of it. Another use case might be like, you know, doing a lit review or reviewing someone else's work, or even systematic reviews. Like there's kind of lots of different places where that might fit into your work or into research in general. And so this is just one of many methods that people have, but this in particular is just a very simple solution to the problem that's just using the citation network. So like when we're using traditional keyword search for papers, you know, you could search for something, inserting keywords, and you're finding papers, but you know, you can, it's pretty easy to overlook something if it's a slightly different word or different language or whatever. And so the key thing here is that we're just using the citation network. So in this example, it's using a tool called litmaps. And this is in particular is called the Discover tool in litmaps. And that's free, anyone can use it, but basically you pass in a set of papers. And so in this diagram on the right, all your papers are in pink in the middle. So it might be a collection of papers you've already created, it might be just 3 or 4, could be hundreds. And then the litmaps will look through all of these papers' citations and references, their connections to each other, and then also like a even bigger kind of picture, like all these different connections. And amongst all these papers' connections, what are the most connected papers that we haven't yet seen? And so that's kind of the main thing. It's like, okay, well, we can see that these papers that are recommended, these are the most highest ranked, most connected that we haven't yet explored. So they could be really interesting. And they could also be something that's like the project we're thinking of, and that we don't want to do the exact same thing. We want to make sure we're catching everything that's relevant to us. And then the one last bit here is also the date filter. So like this one, for example, is set like I took all this literature and then I looked at what's the new stuff, what's been published after 2020. That's also connected to this topic. So yeah, that's kind of the key thing here. And yeah, it's kind of about spotting research gaps, spotting missed papers. And then I did have one more thing that if Adrian wants to click. It's just a very small thing. It's my own little plug, because I actually just also wrote another article about the reproducibility crisis and other like meta research stuff. And I just wanted to mention it because actually that article is not about this tool. It's about another thing even that, yeah, because we only have 3 minutes, but I won't talk about. But yeah, if you're curious or you want to check out yeah, my newsletter on that stuff, then please go to the litmap Substack and yeah, thank you guys.
Thank you, Marina. All right, next up is Kathy. Kathy doesn't have a slide, so I'll go back to the main slide. Kathy, do you want to unmute and give us your tip?
Yep. Thanks, Adrian. Thanks for organizing this. Hi, everyone. I'm Kathy Zeiler. I'm at the Boston University School of Law. So I sit in a law school, working in a law faculty, and I'm going to put a document into the chat if I can. Let's see if I can make this work. It doesn't want to take it. Let's see. I'll get the document into the chat. But I've been working, writing about how scientific findings get applied in legal arguments. So these could be legal arguments in legal scholarship or in briefs to the court, any kind of legal argument or policy argument. And meta science has given us something new to think about when it comes to application. And in particular, we might think about the credibility of the science that normative legal scholars or brief writers rely on. And one of the standards that I and others like Jason Chin, who I see is also in the meeting, have been advocating is the creation of appendices that report what I am going to call indicia of really appraisability, if that's a word. So just the ability to appraise a particular piece of science, a particular finding or a set of findings. And so we think it's important now, given what we know from meta-science, to really get a sense of, to give readers a sense of how appraisable the findings are that are being relied on to support normative claims or even descriptive claims in law. So when I say normative, I mean issues about what should we be doing. For example, should judges be required to take training on implicit bias? So in our view, anyone who relies on scientific findings should report on features that make the findings more or less easy to appraise. Right. So this is the key. So these indicia are not necessarily speaking to the credibility of the work per se, but just it's the ability of other researchers to appraise the work, to actually correct the record if it needs to be corrected. And so we get our inspiration, at least I do, from in part from an article by Samin Vazir and Alex Holcomb in 2022 issue of Review in General Psychology called "Where Are the Self-Correcting Mechanisms in Science?" And they walk through, and I'm at the end of my 3 minutes, some indicia that we can look at to assess whether or not the record is correctable. So I'll drop the tips for searching single research articles for these criteria. And if you're interested in doing this, I think there are a lot of different applications. If you're interested in doing this, please get in touch with me, and I can give you a link to the Google form we set up to have our research assistants do this. That's it. Thank you.
Thank you, Kathy. Next up is Lucia, going to talk about protocol writing. Oh, Lucia.
Yeah, hello. I'm Małgorzata Lagisz. I'm a research associate at University of New South Wales, Sydney. My background is biology, and transcribing my name. It's always wrong. And I do lots of systematic reviews and meta-analysis. We also occasionally do primary studies. But in context of open science and meta-research, there is this big push for publishing protocols, or at least registering your research. So actually, I do a lot of reviews for protocols being submitted to journals. And one of the most common issues is that people write the protocol from the head or from the literature, and they don't have any evidence that this stuff is going to work. They don't do piloting. And my key tip is that piloting either key elements of your protocol or all elements, if possible, of your protocol is absolutely essential, because only then you can tell if this stuff going to work. Do you need to modify it before you start the whole study and halfway you realize this doesn't make sense, it's too big or it's too small scope, or that method that some other people used doesn't really work well in this context and you need to modify things, make shortcuts or do additional stuff. So if you do piloting of key elements on a small subset of what you are doing, in empirical stuff, I think people do that sometimes, like rather than running whole study on hundreds of animals, they will do a little bit similar work on just a bunch of those and see whether it's feasible. So we can do it for all sorts of research, especially for meta research, because we don't really need like real animals or whatever real environment. We have usually some sort of data, which is in digital format. So we can pilot everything. We can pilot literature searches. We can pilot data extraction. We can even do tiny pilots of the analysis on simulated data or tiny subset of real data. And it's not really like you are conducting the study, then seeing the results, and then writing the protocol. It's really the piloting step. So that's something I recommend. It saves time and frustration later on. And yeah, I think it's the best thing we teach our students and collaborators, so they don't need to go back and fix their study later on. Thank you.
Thank you, Lucia. Lydia is up next. Lydia does have a slide on small sets. Go, Lydia.
Thanks, Adrienne. Hi, everyone. My name is Lydia Lucchese. I'm a fourth-year PhD student at the Australian National University, and I research data pre-processing. Data pre-processing is that intermediate stage in data analytics where you have to resolve any dataset issues and figure out how to transform, clean, and format your dataset for the analysis. Pre-processing work is an interesting blend of problem solving, creativity, detective work, judgment calls, domain knowledge, and statistical knowledge. And ultimately, it's a decision-making task, sometimes a difficult one, that can have downstream effects and influence analytical outcomes. So my tip for you today is to check out the Small Set software, which is a tool to help you document and communicate these important data pre-processing decisions. Small Sets is an R package that builds something called a small set timeline, which is a visualization composed of small data snapshots of different pre-processing steps. It uses a small set of rows from the data set to illustrate how that data set is changing. In each snapshot, colors highlight data edits, additions, and deletions, and a snapshot caption describes each pre-processing step in more detail. And you can see an example small set timeline on the slide. Now, to build this figure with small sets, users simply need to add structured comments with snapshot instructions to their pre-processing script. These comments tell small sets where to take snapshots of the data and what the snapshot captions should be. In other words, users document their code and build a small set timeline at the same time. There's an example small sets comment on the slide, and all comments follow this format: hash small set snap, then the snap place, the name of the data object, and the snapshot caption. And although small sets is an R package, it also works for Python scripts, and the commenting system is the exact same. Because the small set timeline is a static compact figure, it can be easily included in academic publications, reports, GitHub README pages, in data sheets or model cards. And it's a way for data practitioners to be transparent about how they've prepared their data set, in turn providing others with accessible pre-processing information that's relevant to both understanding and replicating analyses. Small Sets is available for download from CRAN, and I invite you to check out the Small Sets website, try the quick start example, and please do not hesitate to reach out to me with any questions or feedback about Small Sets. Thanks so much for listening.
Thank you, Lydia. Next up, Gerben.
Hi, everyone. It's 2 a.m. here in the Netherlands, and it's so good to see you all here. My name is Gerben. I'm a clinical epidemiologist with a strong passion for high quality and transparent research. Let me introduce to you our open science checklist that we have developed at our center of expertise called Urban Vitality. The research we do at the center with around 130 researchers is all in applied health research. Now, before I go through the information on the slide, let me share with you the inspiration I recently got from a magnificent book called The Checklist Manifesto. It's a book written in 2011 by a guy called Atul Gawande. And so I will, over the next minute, quote a little bit from his book or paraphrase it. Checklists are used in applications that are less critical than flying jet planes or performing heart surgery to ensure that no step is left out of a procedure. He also notes that, as we have noted at our center, that people are built for novelty and excitement, and some of us may feel it beneath us to use a checklist, almost an embarrassment. Checklists may be perceived as coming from finger-wagging support staff who may be as beloved as the playground safety patrol by many researchers. However, the beauty of a checklist is that when researchers use a checklist, they improve their outcomes with no increase in skill. So actually, they embrace a culture of teamwork and discipline. So let's move now to the slide that I prepared. In the top left-hand corner, you see the 14 principles of our checklist, and they cover the whole research project from the very start to the very end. So to give you a few examples, it's about justifying the relevance of your question. It's about involving end users. It's about pre-registration of protocols and statistical analysis plans, all the way down to open access publication and fair archiving of your data. The 14 principles correspond to 14 chapters of an online open science manual. So each of the principles is explained, the why, the how, the when, the where, to actually apply these principles in very short chapters, so they're not very lengthy, so people can access them easily, and they're no longer than 2 pages per principle. And to back that up is our team. We have a team of some members, a qualitative methodologist, a quantitative methodologist, a privacy officer, a data steward, and a librarian, a search specialist. So there's actually 3 components to it: the checklist, the research manual, and the team. And as a final remark, in the top right-hand corner, there are the 4 inspirational sources that are actually behind the checklist. And these are the Netherlands Code of Research Integrity, the literature on avoidable research waste, the literature on the replicability crisis, and a good deal of the literature on open science, emphasizing citizen science, for example, and fair data storage. It's not too easy to implement it for the reasons that I gave you at the very start, but we try to implement it at the level of the institute as well as at the level of the individual researchers. Thanks. That was it.
Thank you, Gerben. Extra points for logging in at 2 a.m. Okay, next up is me. Let's see if I can time myself and do this. So I wanted to talk about doing a scrambled analysis, which is something I do routinely now. So here's an example. This one's from a randomized trial. So let's say we have a randomized trial. We've got our key exposure, treatment or placebo. What I do is when it gets to the analysis stage, I create an entirely new randomized treatment that's obviously completely nonsense. And you can see here, I do it in R Markdown. So the wonderful thing about R Markdown is you can create the entire analysis plan, get everything ready, run it on your scrambled treatment, and then I show that report to all the investigators. And I ask them, is this the final analysis you want? Now, of course, as Lossie said earlier, we should have a protocol. We probably should have stats analysis plans as well. But I do find, and I was talking with Jenny Louise, another statistician, about this the other day, that unfortunately people don't think about what they really want until the last minute. So by giving them this analysis plan, but not analysis plan, actual analysis, you force them to go through every picture, every figure, every table and say, is this what you want? Is this what you want? Is this what you want? It's also, I've found useful as well sometimes for finding little errors in the data that can be fixed up. And you can make all these decisions without worrying about statistical significance, without worrying about, are you nudging the analysis towards something that you want to see? And somebody, when I did this with them, they said, oh, you don't trust me, do you? And I said, no, don't trust you. I don't trust myself. I don't trust anybody. Because unfortunately, especially with some trials where you've been working on them for 3 or 4 years, there's this natural inclination to want the results to be in a certain way. So you send it out to everybody. And then the really nice thing is, once you've got sign off and everybody's agreed, you just click a button, change the scrambled here from true to false, and you get the actual report with the actual results in it. So it's kind of a very last stage that can be used to quickly enhance, I think, the reproducibility of results, because we're getting these decisions about the analysis fixed in stone, and any analysis that people ask for after now, I always insist on. People don't ask as much, they still do, but I always insist on this is being flagged as clearly a post hoc analysis. All right, next up is Tom. Tom doesn't have a slide, so I'll go back to the first slide. Go, Tom.
All right. Hi, everybody. I'm Tom Hardwick, Research Fellow at the University of Melbourne. So my tip is sleep soundly with push-button reproducibility. So many of us will have received an email query at some point about one of our papers, and we return to an old project folder to find a menagerie of incomprehensible documents with various names like version 3_final, version 3_submitted, version 2_final comments from Steve January or something like that. And it's all a complete mess. So I suspect that many scientists are reluctant to share their data and their analysis code because their data management and analysis workflows are pretty messy and disorganized, and they're basically worried about people finding errors in their work. Unfortunately, burying our heads in the sand is only going to make matters worse, because those queries about our papers are going to keep coming, and those scary folders of badly managed data and code are going to keep gnawing away at our conscience and keeping us up at night. So fortunately, there is a way to address this problem that is both good for science and leads to a restful night of anxiety-free sleep. So the solution is something called push-button reproducibility. This is not a novel idea, but basically the concept is that with every quantitative paper, we share a digital container that holds all of the relevant data files, all of the relevant analysis scripts for our project, and it also has all of the relevant software packages that you used when you ran the original analysis built directly into that container. So we don't get any annoying errors popping up just because software has been updated over time or because we're using different computers to run the analysis. And then the finishing touch is that in that container, you have a single master script, which tells the computer how all of these items in the container work together to produce the results that are in your final paper. So it's a bit like having a recipe book that automatically combines all of the ingredients and produces the same meal every single time. And the beauty is that all anybody has to do, including your future self, is to push a single button on that master script, and that will reproduce all of the results reported in your paper from scratch. So you no longer need to worry about tracking down where the numbers in your paper have come from. So there are various ways to actually achieve push-button reproducibility, which is far beyond what I can talk about in 3 minutes. But I'll recommend a platform called CodeOcean as a really good way to get started with this. I'm happy to share examples from my own work and also point you to more resources if you drop me an email. So that's it, and sleep well, everybody.
Thank you, Tom. Perfect. Next up is Marty. Marty has a slide and a quite excellent acronym too. Go, Marty.
Perfect. Nice to meet everybody. I'm Marty. I work at Neuroscience Research Australia, a physiotherapist by training, and running clinical trials as well as a neurophysiologist. So as academics, researchers, and scientists, we have the responsibility to report our findings clearly and accurately. Unfortunately, the quality of reporting in published research is often poor, and this even in the most prestigious, and dare I say, impactful journals. I've had a long-standing gripe with poor research reporting myself. I've written letters to the editor. I've conducted audits and surveys that highlight the severity of the problem and some of the contributing factors. I'm also the co-chair of the Research Quality Subcommittee here at Neuroscience Research Australia, where we wanted to find a simple, short reporting guideline or assessment tool that we could use to assess the papers published by our own scientists. The goal here was to identify practices that we do well, but also identify the practices that we don't do so well, around which we could develop training and educational activities. Unfortunately, no such tool was available when we searched a few years back. So we took on the task of developing a simple and broadly applicable tool to assess key aspects of research quality relevant to biomedical publications. Our guiding principles were as follows. First, our tool should focus on peer-reviewed publications or original findings. Second, our tool should include relatively few items, and these items should focus on research transparency, research design, and research reporting. Third, anyone with a working knowledge of biomedical research should be able to administer the tool. No field-specific or statistical expertise should be required. In essence, we wanted a tool that targeted the low-hanging fruit of open science and research quality. And who better to target these low-hanging fruit than Australia's very own low-to-the-ground quokka? Our quokka, which consists of 11 items, was designed to guide discussion, not rate or rank researchers on their publications. As such, it does not generate a total score, as this can lead to superficial changes in research practices. Slowly but surely, we are administering quokkas to all the papers published at NEURA since 2017. While our institution does some things well, there is room for improvement in areas such as registering our study protocols, making data and code publicly available, properly reporting measures of variability, and avoiding spin. But we are hopeful that the growing awareness of these issues and our own educational activities will lead to a positive change in the reporting practices of more recent papers published in our institute. Soon, we will be making available educational modules and online resources to further assist people who want to learn about research quality and the quokka. But if you can't wait for the cuddly goodness of the quokka-related material, please check out the paper we published in BAMJ Open last year that presents the quokka and also provides a helpful manual of how to apply the quokka. Thank you.
Perfect, Marty. Lucia, you're up again, talking about recognition for open science this time.
Okay, so the disclaimer, this is the only item with a question mark. I submitted it originally as a question, hoping to get some tips. So, but I will use it as an opportunity just to promote a few things. So one thing we've done recently, 2 studies looking at awards in science. Best Researcher Award, Best Publication, first in Ecology and Evolution, and now we are completing project on Best Paper Awards across disciplines. And what we found every time, there's almost no award criteria or awards that are dedicated or mentioning transparency and robustness and reproducibility as part of what award is for. So traditional awards don't care about open science or how transparent the research is. I don't think publishers really practically care about it, apart of asking people to tick their checklists that they are not checked later. Anyway, and most societies, organizations talk about a lot again about research quality, but not really how that translates to reproducibility and replicability and transparency and everything. So there's a huge gap, and there's a few new initiatives coming. So one is from AIMOS. AIMOS has awards for open science, people working towards improving science for meta research and special initiatives. So check out the AIMOS website for awards section. And the other initiative is by SOTI, Society for Open, Robust and Transparent Ecology and Evolution, which also has awards specifically for open science. And at the moment, submissions are open, and deadline was extended to 1st of October. So we have awards for early career researchers and for any researchers for using in practice open science approaches. But I would like to hear from you, how to create incentives for doing open science and meta research, how to integrate that with a research system to improve science in general. Yeah, thank you. I'm not sure if I went over time. I forgot to press the button.
Next up, Matthias, we've got 3 more left. Matthias is going to talk about self-publishing models.
Hi, hi everyone. I am professor of theoretical physics and pure mathematics in Brazil. Today, I'd like to share with you a unique method we have discovered to sort of bypass the traditional publishing system. The Open Journal of Mathematics and Physics operates on a self-publishing model, meaning it was created by editors who self-publish their work. It's an overlay journal based on the Open Science framework from the Center for Open Science. All papers have DOIs and are indexed on Google Scholar. At the Open Journal of Mathematics and Physics, even though most of our publications are in awaiting peer review status, we have received over 1,000 of citations for 270 papers. Our journal publishes white papers, which are succinct articles presented in a numbered bullet format. A significant feature is that all papers can be updated after they have been previously published. The journal has been operational for 4.5 years, and this year it was recognized as a scientific journal by Brazil's federal agencies. It is deeply established within the Open Science Protocol. For example, there is no limit to the number of co-authors. Papers must be fully reproducible, and collaboration is valued over competition. Besides self-publishing, we accept external submissions as well. The criteria for publication focus on correctness and reproducibility, not necessarily the potential importance of the research outcomes. This is because determining the potential significance is almost an impossible task to consistently achieve, in our view. For instance, regarding reproducibility, since we mainly publish theoretical works, every step must be included in the white paper. You can find the Open Journal of Mathematics and Physics at ojmp.org. We hope in the near future, many more scientists will adopt the self-publishing model. It is crucial that researchers reclaim the influence over scientific publications, given their pivotal role in the field. Thank you very much.
Thank you, Matthias. Maybe put the link in the chat there, because I've shared the chat on the YouTube channel.
Okay, perfect.
Thanks. Yeah, and we probably should talk to MetaRaw as well. So we've got a coming platform journal in meta research that's going to be launched soon as well. But that sounds really interesting. Thank you. Okay, next up is Simon to talk about Retractions Australia.
Thank you for organising this, and thanks to all the speakers for some very interesting presentations. Retractions Australia is a new website set up in May 2023 by researchers at Neuroscience Research Australia in Sydney. And the aim was to provide a high-quality searchable resource. Now, the website highlights every paper which has been retracted and which has an Australian or New Zealand author affiliation. What are retractions? Retractions are published scientific papers that have been withdrawn by the publisher, authors, or their institutions. And this may reflect the detection of an overt error, but much more likely it reflects fraud, fabrication, or plagiarism. Now, why is it important to know about retractions? A story. Imagine you're a counsellor on a national body, and your task is to select winners of a national science award. The council debates the merit of the candidates and ranks them. But no one mentions what you know. One candidate has several papers mentioned on PubPeer for questionable scientific practices, and one of their papers is already retracted. Should that candidate receive the national accolade? Probably not, at least not without further investigation. Now, I've been in that position twice. My colleagues didn't know about the public evidence of the candidate's shonky scientific practices, yet it was in the public domain. So if you intend to work with someone employ someone, give them a special award, etc., your assessment should include a check of their publicly available profiles. Our Retractions Australia website is produced with cooperation from the main Retraction Watch database in New York, and it's one tool that you can use to check this. Finally, why should you be worried? Well, it's estimated that around 2% of published health and medical research papers have got questionable images. And different forms of analysis put that probability of research being seriously shonky at much higher than 2%. Some new analytical tools are making it easier to estimate the magnitude of the dodgy papers. But on the other hand, generative AI will be making it more difficult to detect the fake work. In one way or another, the public pays for our medical research, and it should be able to rely on the output of the work. So our health and our well-being ultimately depend on getting this right.
Thank you, Simon. Okay, last up is Fiona, Join a Society.
Hi. We've left the filler for last. This is a very simple tip, really hardly a tip at all, is that this is something we all do anyway in our substantive fields. We join societies and go to conferences. I just wanted to draw attention, I guess, to the growing number of societies related to meta-research, open science. And these, I guess, provide an opportunity for us to learn new things, obviously, but also, I don't know, complain about stuff going on in our everyday lives and find sort of a safe space to do that in, and maybe work through sort of scripts or arguments to rehearse those sorts of arguments that we can use with our other colleagues outside of these spaces. So I just have on the slide a number of kind of opportunities. Some are disciplinary specific, like sortie is for ecology and evolutionary biologists. SIPS is, of course, well known for psychology, STORK for people in sports science and kinesiology, AIMOS for everyone, and then some other things that aren't quite societies, but do provide opportunities for kind of community interaction and networking. So AusRN has a Slack group that you can sign up to. Reproducibility is a journal club that Tom and Beth, who are both here, are coordinators of, and it's online, so you don't need to be in Melbourne to join that. And Metascience is another conference, but obviously the first one coming up on this list is AIMOS in November. I hope to see you all there.
Thank you, Fiona. Yes, I did want AIMOS to be called the Society for Moaning About Bad Research, but you know, I got voted down. So. Okay, thank you, everybody. Thank you, everybody, for sticking to 3 minutes. Thank you, everybody, for good microphone hygiene as well. And yeah, just as Fiona said, the next big conference, or well, from my perspective, the next big conference is in Brisbane. If you want to hear more about meta research, come up from the 21st to 23rd November. Registrations are open, and I will put a link to the conference website in the chat. Okay, what I want to do now is, if anybody feels they can share their own tip, or if anybody's got a question about a tip. And I should add one thing I wanted to add to mine. It's my scrambled analysis is not just for randomized trials. You can do it for observational studies too. So if you've got a question, maybe please raise your hand, given the number of people, or if you want to share a tip. Okay. Give it another 30 seconds and then we might end up. Oh, I should put the conference. Well, I'm just going to put the conference link in the chat while people are thinking.
I've just got an administrative question.
Question, Trung. Go, Trung.
Hi, everyone. I'm just on the move, so thanks, everyone. Really great talks, really useful. I don't know if anyone's ever proposed it, but seeing all these tools, because I also do work in bioinformatics, have helped to support an open bioinformatics platform, an open science platform that sort of integrates lots of tools. It's almost like a new tool coming out every day, and instead of going to 100 different websites and different sets of code, the platform integrates new tools into it so that anyone can just go in and use it. So there's been proposals to try to integrate many of these tools into a platform, and where people can just go in and use it more readily, and then having to go into disparate tools. Thanks.
Does anyone know the answer to? I know the Open Science Framework does coordinate some educational materials, as we were just looking at yesterday. But no, Trung, I don't think that's been done. Okay, sorry, I don't know how to pronounce your name. Aselin?
Aselin.
Aselin, yeah, please go.
Aselin from RMIT University. Great workshop today, really useful points. I just had a quick question. I've got a PhD student who's really interested in impact evaluation and learning R coding, and just thought if anyone has any good pointers to just good resources that I could point my student to who's fairly new to coding, just for general reproducibility practices for using software in general. Because I haven't, I mean, there's lots of disparate bits and pieces all over the place, but I haven't seen any good sort of introductory resource that I can just point a student to really get their head around a lot of these practices. And if anyone's got any good ones, I'd really appreciate if you could just put it in the chat. Thanks.
Thanks, great question. Yeah, I know there are, I will try and dig some out, but there are some books in R that have code and are all open source, and yeah, but if anybody wants to answer Aselin's question while we're going. Pavel.
Yeah, hi everyone. I'm just doing that. I've just posted a link in the chat. There is a very good book, The Plain Person's Guide to Plain Text Social Science by Kieran Healy from Duke University. It does just that. And as a follow-up to this R Markdown discussion, there is a very good introduction to the use of plain text for social science and for meta science in general. So I highly recommend it.
Thanks, Pavel. Yeah, and I see Tom's posted Hadley Wickham's book there as well, which is, yeah, I really like that one too. My stuff that Hadley Wickham does is really very good. Oh, and there's some more in there. Thank you, everybody, for that. All right, well, like I say, I will save that. This video will go up on our YouTube channel, and I will save the chat and paste it in there so that there is a permanent record of it somewhere. Okay, it feels like the questions are coming to an end. So I just want to thank everybody. There's definitely so many things to think about there, all the way through from searching literature to how you run an analysis and how you rerun the analysis 6 months later when someone contacts you about it. So I think that's been really useful, and thanks everybody for your time.